Awesome. Okay, so for this week, for this week, hopefully y'all know you have lab 4 today, and then your midterm. I think that's Friday for most of you. Yeah, some people have like DR Disability Resource Center exceptions or like whatever, but for most people it's March 5th from 5 to 8 p.m. If how long is it? 90 minutes. So make sure you take it 90 minutes before 8 p.m. because that's when it's due. So make sure you take it March 5th. What is that? 6:30? Yes, but by 6, start taking it by 6:30. So you have an hour and a half to start taking the exam. And then you get 90 minutes. Looks like it's lockdown browser and webcam for you guys. So you'll have to turn on your webcam for that, get that all done. I bet there's like a lockdown practice quiz. Yeah, lockdown browser practice quiz. You could do that before you try to take the midterm just to make sure that all works. If you have issues with Respondish, I mean, you can message me, but you need to make sure this works. Like that, like you are in charge of making sure this works before the exam. So you don't like you do have this practice beforehand, and so if this works, then the other one should work. But yeah, if it's not working, feel free to message me and we could try to do something. But most of the time, that's just like sucks because you have access to this, and so we'll tell you to try this. It's not with proctor use. You don't need to schedule anything, which is really nice. That's an F. Oh, that kind of thing. Oh, yeah, that kind of thing. Message me because I can look, but make sure you message me right away for that kind of stuff. Because I can like look and I'll try to make sure that I'm online during that time. I can make sure I'm doing that. But yeah, message me and I can look to see how long you were on the quiz when you actually crashed. And so if you took 2 seconds to message me after it crashed, then I can give you another attempt and I'll just throw you back in. But well, that's not a guarantee. It'll be a case by case basis. Really try not to crash. Okay. So yeah, if lockdown browser crashes, then nothing is being recorded anymore technically. So yeah, you can just open up Slack, message me. No one should be talking about the exam anyway because there's going to be people who are taking it later. Okay. So yeah, make sure you're prepared for that. If you have any more questions about that, always feel free in the chat. So yeah, midterm. So today we'll be going over lab 4 midterm stuff. And then I guess binary file IO is what like actual the module for this week is, but that's not what we're doing. Yeah, we're just going over lab 4 and then the midterm study guide in here today. To start, I'm going to do lab 4 just because the midterm, I know this is probably more on y'all's mind since it's due sooner in 2 days, but I'm going to go over the lab first just because this is bigger. And so if anyone's like, I'm already prepped for the exam, then they don't need to sit through a bunch of this whole shenanigans. But yeah, lab 4 first. So lab 4. You're going to be reading CSV files. We talked about CSV files last time. They have the delimiter in them. That's the comma and main line for a whole new line. You could open them in like Excel sheets because it makes each cell a comma separated value and then a new row is a new line character kind of thing. So yeah, each Lego set has a bunch of this data right here. It's all right there. There's no bad values, so you don't have to check for any of that, but there's a bunch of information. And then you have to read from these things, get all that information, and then you're going to have to do a couple of different algorithms depending on what they choose, what the user chooses to find information. So like you're going to have a whole list of things, what prices would stuff be and all that. For formatting, like always, you can go to Zybooks and look at the formatting. for what people want. So honestly, it doesn't even look like there needs to be a menu. Yeah, I'm not seeing anything about like a requirement for a menu or like telling you what input needs to be. But when they give you certain input, then you just got to do it. And actually, I think has what always been there? The output examples? No, you don't get to see that. You get to see that when you submit once. Yeah, you get to see that once you submit once. So submit, you could probably just submit nothing, like you could just submit blank, non-compilable code, and then we could see what you see. Yeah, this is something that I specifically see. But this is what you get to see. So yeah, when you submit just nothing, you can see all these tests. Let me hide. But yeah, there's nothing like special. I wouldn't open up the solution one because that would be no. But you could. These are all the tests you have, so you can look at them for that. And actually, it looks like the menu and stuff is already given for you. I knew there was something about the menu doesn't matter. Like we weren't focusing on that this time. It's just print the get the loaded and get the information and print the information. Oh yeah, load the data, print the data. So it's all that the format of the options menu and stuff is already set up for you there. You also have just an extra file if you want it. Some people do, some people don't. The class that you make for this really shouldn't be that complicated. If you want it to be, go for it. But here, let's download. So this you do have access to. You download these files. That's how you get access to them. I'm going to save them on my desktop, sure. Extract all. There. So now you can open up any of these files. And you can see in here what the CSV looks like in an Excel spreadsheet. But if you're trying, so this doesn't have any of the commas. So if you try to read this, you're like, why the fuck is there no commas in here? That's because if you go and open it up with some sort of text editor, so like Notepad, I'm just gonna use VS Code, so I think it looks prettier. So right here, this is what it looks like internally. So it's just values separated by commas. Oh, and then there's a new line character at the end. So we could even practice opening this up. So go to here, new project, and the first thing I'm going to do in a new project is OS stream test test.text test.write hello. Here, since we haven't done .write yet, there. Hello. Test.close. There you go. And then I'm going to run this. Oh, yeah, no, you're going to be the best Lego collector out there, all of you. So it runs. No output. That's what we want. And then I know this already, but if I open up here, that's where this is going to be. So then in this folder, that's where I'm going to put these. There we go. So now that they're in there, I can just comment this out, leave it for you guys. You want to see it. Now I'm going to do IF stream. L1, sure. You guys might make a variable for that. And then just to make it separate, because this is probably how you're going to have to do it. Here, I'm just gonna call it Lego. Lego.open Lego1.csv. And then from here, using this, you have a bunch of different ways to get this information, but with the setup being like this, with lines of information, you should probably use getLine. So I'm gonna do string line, and then getLine, Lego, comma, line. And then I'm gonna do a while. No, I got, yeah, I'm just gonna leave it. While getLine. And then cout line endl. So with this, probably the most basic, receiving input from a file and then printing it out. Nothing fancy. This is just all of the lines in the file. So getLine by itself just uses a new line as a delimiter, you could say. So it's getting all the information out. One thing to note here is that this first line, number, theme, name, minifigs, prices, US prices, that's important for someone who's reading it, but we don't actually want that when the computer is reading it, because that's going to break if you're trying to parse all this into information. So we're just going to do a singular get line beforehand, like that. So that's just going to like throw out that first line basically, because it's reading that first line and then it's immediately getting overwritten. And then I guess I don't know if we talked about it, but getLine returns true or false, whether or not it received information or not. So you can kind of use it like this, which is nice. Okay, and then from here, let's add, so if we run this now. This is great, but we wanted to use commas as delimiters, not new line characters. So let's do that. So to add a new delimiter, throw in a comma. Now this looks great, but I'm gonna add a little separate thing to show you a possible issue with this. So if I do getLine that, and then line, let's add a second end line. You must be asking, Steven, why are you doing a second end line? That's a great question. So if it runs, now here, there's something a little weird about the spacing every once in a while. You can't see it as it's just like scrolling on by, but let's let it completely finish. It's gonna take a second. But every once in a while, there's two numbers right next to each other. There, there, there. And when they're right next to each other with what I've done here, that means that it's not, yeah, when they're right next to each other with what, shrink that, there we go. That means that it's not, that's it, when it's like this, that means both of those things are part of line, the line variable that I have. And that means that they have a new line built into themselves. They're not doing the new lines, the extra new lines that endl does. Why that's happening? CSV files, they're comma separated values. Each of the values separated by a comma. However, each line of information is separated by a new line character. There is not a comma here. Y'all see that? Comma, no comma, comma, no comma. There is no comma at the end of these lines. What is delimiting them is an end line character. So you could not just do this to get all the information separated, because now they're chunked together like this. So this is one chunk of information. That's one call of getLine stores this whole thing. So a part of the challenge for you guys is to figure out how to parse this information so that you get 1, 2, 3, 4, 5 things delimited by the comma, and then the last thing isn't. There's a couple of ways to do it. The first one is to not parse by comma initially. So you break up the text information like this. And so now if it runs, so now line is now each chunk of information is completely separate by this line, and then you could now parse the line value, so the line variable itself. That's one way to do it. The next way to do it is to, since you know, since you know that there's the 1, 2, 3, 4, 5 values with a comma, and the last one's a new line character, you can call this there we go. Question. No. You guys don't know about string streams, do you? Okay, so get line, the first thing has to be a stream. The second thing has a stream, an input stream, and the second thing has to be a string variable. So yeah, new line is fine, but that first thing can't just be a string. So line would have to be a stream, but there is a concept of a string stream. We haven't talked about it yet, but I assume T might have, but we can go over it real quick here. So a string stream is initiated a lot like, is there a get line in here? Get line, there we go. So this is get line first string stream. So there's some examples here. Yeah. So there's some examples of a string stream. What? That's not a string stream. Oh, this is just get line and it's just I stream. Oh. So initialization then was there. Constructor. There we go. Okay, so here's how you can construct a string stream. Oh, can I have a more constructor with parameters? Okay, it's not giving you one. You can create a string stream like this. Oh, I have to include it at the top. String stream there, and then in the constructor pass in line like that. And so now there is a stream that you can use get line with. So now you could do your thing. You could use get line there, and then a string, and then a delimiter. But I won't show that because I'm leaving that up to you guys. But so that was the first way, and then the second way is with the new delimiter and stuff. Cool. Yes. So it would get line. No matter what stream you're using, it works with delimiters and strings and stuff like that's consistent. You just know F stream, IO stream. So now you just also have string stream, which is a way to parse up a string. So yeah, and then the second way is since it's a known quantity of elements in a thing, we can go into here and write that number of elements. So I'll do two. I'll just do a couple, and then end it with a get line. So if we run this, ooh, actually I did not want to do that. I want, no, I'll do it. I'll do it. Yeah, this is fine. This is fine. Okay, so with this, so we have 3 chunks of breaking up. So one get line, another get line, 1, 2, 3 get lines. The last one not having a comma as a delimiter. So in here it's 1, 2, and then a couple of commas in that one, but it goes until the end of the line. So this gets like to the 10, and then this one is 4, 8, 5, 8 for juniors, and then 3, 55, 15. So you can break up the information that way and just do multiple get lines inside if you're storing the information like this. I guess that's storing, but this is just a way to show that I at one point stored it. You might have to manipulate it a little bit after the fact. But so yeah, that's the second way that I know. Obviously, if you find another way, more value, more strength to you. That's the little thing I was looking for. But those are just a couple of ways. Oh no. Oops. Open that up again. GetLine does not modify the file at all. It doesn't even format the output. I was just formatting the output explicitly by adding end lines there. Yeah, getLine does not modify the file or format the output. It just gets up until a delimiter. GetLine gets information up until a delimiter, and then it modifies, technically it modifies the input file stream object by saying the next place to get information from is X part of the file. So if we call it getLine without a delimiter right here, getLine would get this information, store it in the string, and then tell the IF stream the next place to start getting information from is here. Technically it does that, but it doesn't actually modify this file. It doesn't modify the CSV file we loaded at all. The IF stream keeps track of some information that's separate from the file. Any stream does. Okay, so that's just like opening information. So yeah, that's all like the loading information part. And so all that would be useful like here. You could obviously make those functions like outside of main if you wanted to keep this a little more empty, but that's totally up to you. Once you've loaded all the information like that, oh, I guess we're still in the loading part. You need to actually store it in some way. However you want to break up this information, totally up to you. I've seen people like put all of the numbers into a vector and then all the themes into a vector, all the dump trucks into a vector, all the minifigs, pieces, US price, all their own vector. And so they kind of kept track of everything with index. I don't recommend that, but I've seen it. I've also seen someone just store each individual element in a vector and like go with like a 1D array, and that was wacky. But they're living their best life. The more recommended way is that you can see that a Lego set is an object, and all of these are parameters. All these are like member variables of an object. So you can make a class with those member variables, and we even like say it down here what these things are. Set number, theme, name of the set, how many parts. use price dollar, use a double, not a float. So all these things could be member variables of a class. And so I highly recommend making a class or struct. Probably struct would be better, honestly. And then creating a vector of that struct of that data type, and that's what you could use to store all this information. And so then for if you're just loading Lego 1, then just, or Lego 2, Lego 3, if you're loading individually, then you just have a singular vector. And if it's all of them, then you just store all of them into a big vector kind of thing. So yeah, store, search. So yeah, right, any class or function you think you want to solve this problem. So I'm not telling you you have to do anything. I promise you, like, you can write this however you want, live your best life. Like, part of this class is figuring out what works best for you when you're writing code. But some things will help more than others, in my opinion, but that's mine, not yours. Now, once you've got it all stored, so theoretically, now you've got all the storage stuff. It's in something that you like. You can get access to the information you want. Now, for depending on which option is chosen, you need to print out how many sets were loaded. Okay, that's important, I guess, for some of these tests. Sure. But then now, based on the choice, you need to do the appropriate searches and calculations to find like the most expensive, the largest piece count. So that's all search. Search for set name containing, search themes, part count information. What's that? Show the average. Okay, so this, like, so yeah, all these ones up here are searches. So you'll need to search through whatever you're storing, however you're storing. Part count, price information, minifig information. If you bought one of everything, all of those are calculations. So you'd need to go through all your information, sum them up or average, and then print that information out in the format we say here. So all those, just like whatever you're using to search, load that information for you. For averages, that's just adding up values and then dividing by the number of how many there were. If you got one of everything, that's just adding up. Some of these searches, like search for a set name containing, so fire stations, that gives you fire station and big fire station. That one, how do you find a certain string inside of another string? If you just search string C++, it's like, what can we do with the string? Oh, hey, look at that function. That might be useful. So yeah, we've worked with some of this stuff before. So like the find function, I'm not trying to be like, I'm just showing you that it is a thing. So that'd probably be super useful for these. We've worked with that before. Most expensive, there's not a find for that. You're just comparing values. Same with largest price piece, the largest piece count. Just lots of comparisons. But yeah, all that, it's not that bad. Reading mixed data information. So yeah, you're always reading in strings, but then if you need to convert string to something, is Stoy on here? Hopefully. Stoy? Oh, it's on the right here. So yeah. So on the left here, there's these functions that you have access to. Most of them is like stod, stop, stoy, stoled, bigger stool, two string, two W. I don't even know what 2W string is. But all of these stand for something. String to float, string to int, string to long double. Or what is this one? Oh yeah, long double. Cool. String to long, string to unsigned long, string to unsigned long. All of these are string to something. So if you think that, we've worked with this before, if you think that a number shouldn't be a string but stored as like a certain number type, cast it to like, this is a double, this is an int. How many parts? That'd be an int. that kind of thing. So cast it to the right data type so it's most useful to you if you want to. And we worked with that before, and I think I said it last time. If you ever run into an error with that, the first thing you should do is just put a cout statement before your call for stoy or stod or whatever, and see what you're passing into the function. Because I'll tell you real quick what the error is. Big yawn. Okay. So yeah, before you start this, make sure you really think about how you want to store information or retrieve information, because you need to be consistent so that initial choice impacts the rest of your program. Having good storage makes things a lot easier, but really it all comes down to what makes sense to you. The code to load file 1 containing one piece of... Okay, so yeah, that's not important. When passing container to file reference, not by, oh yeah, so pass by reference, not by, so yeah, pass by reference, that's the big thing, it makes things a lot faster. Because this is the type of situation where there's a ton of information, so you don't want to be making copies of this. If you have a vector with all that in there, you don't want to be making copies, we want to pass by reference. Helper functions could be super useful. So like you should probably have a helper function for like loading files. That'd probably be useful. And there's some test output down here. Okay. Any more questions on that? Good general overview of Lab 4. Gabby, carrying the team on questions. Y'all are very appreciative. So make a pointer to those strings. Pointer is passing by address. Passing by reference is by reference. You could pass by pointer though. It gives you more control over the situation. But I was meaning we did a lot of pass by reference in like lab 1 stuff, right? Project 1, I mean. So hopefully you've seen that by now. Not a lot, but we did it. Yeah, like right there. There's a pass by reference in the copy constructor. There's a vector somewhere, right? Find all. There we go. Find all had pass by reference for a vector. So something like that would be perfect. Because you're going to need a vector at some point. I don't think I've ever seen a solution to this project without a vector. Okay. Cool. Awesome. So no reference is the ampersand, and that gives you the data at that point. I low key forgot. Reference is when you've got like int x equals 2, and you do int reference y equals x, and so now x and y are the same thing. Yeah, the ampersand that you're talking about would be like int z equals 10, int pointer a equals address of z. So in this context, it's address of. In this context, it's reference. And both of them are doing stuff with pointers, but one of them's explicit, one of them's behind the scenes. So it can get definitely confusing. But yeah, when we're talking about reference, we're talking about this, because now you can just do y equals 2 or cout just basic y. That this is the better example. So now you can just do cout y, and that's easy. Here you'd have to do cout dereference a and L. Now the thing we're talking about reference in here specifically is when passing containers of data, make sure you pass by reference. Containers data is like the vector, because a vector is storing all this the vector is storing all this information. And so if you pass by copy, it has to copy over all that information. If it's passing by reference, it only has to technically in the back end pass the address over. So it's faster. Get line has nothing to do with the pass by reference stuff. Yes, you make one OG1, then pass by reference, and then everything references that OG1. Yes. Totally fine. I'm very happy that you're asking questions. I'm a big fan. Okay. So yeah, pass by reference. Here's a little refresher on references, and then it's a lot like how we were using. Is it already gone? Where'd it go? It's a lot like how we were passing this vector in find all. So you can use that as a reference to how to pass by reference, but not. Okay. Cool. That was lab 4. Okay. So at this point, we're done going over lab 4, and we're going to go over the midterm. My priority for the midterm is to go over any questions anyone has. If not, I'm just going to kind of go down the list here. If any of these things are giving you specific issues, like if you think you're having trouble on file IO, I recommend going 1 to the specific file IO quiz study guide, because that'll have more questions, so like just a couple more like things. Like, so here, what are the three file IO classes we use? What process we use to read and write? How do we use to separate data and a value? That's great, but then here, like, there's a little more. What classes can we use? What operation we use? How do you write an entire line? So like, this is a little more in depth. So going back to the specific study guide for like the quiz might be helpful if you want more. Going back to Fox's old lecture videos, my old lab videos, we went over like the entirety of these, and he went over like a whole PowerPoint worth of information. Besides that, just like, I don't know, those are the big things. But so anyways, I'm just gonna start going down the list. I'm also gonna turn down my brightness. That probably helped my eyes. They're feeling, there we go. That's so much better. Okay, so midterm exam study guide. Let's go. Classes. What is encapsulation? Encapsulation is the concept of taking some sort of object you're going to write in code. It's like if you are going to write something in code and you think that it could be an object with like member variables and functions, encapsulation is the concept of doing that. So C++ to implement encapsulation uses classes and structs. But the concept of encapsulation is storing information with associated member variables and functions. What is the purpose of a constructor? It's used to initialize an object. What is the name of the pointer of the invoking object, e.g. the object which called the function? That's called the this pointer. The this pointer. What is the name of the function that gets called when an object falls out of scope? The destructor. What is an accessor? What is a mutator? Accessor is any function that returns information about an object. A mutator is any function that changes information about an object. That'd be the basic form of those would be the getters and setters. What are the public/private keywords used for? It's to limit access to information in a class. So public means that you can just say class object dot information, whatever member variable anywhere or function name anywhere. But private means you can only do it inside of the object specifically, like inside the class functions, member functions, class definition. And if I'm going too fast or you want me to go over anything, please make sure to say something, because usually when like I do this in person, I'll just like read a room to see people's faces. That's not a concept anymore. So you just got to say something. But I will happily stop or slow down. So const, how to create a constant variable. So that's just the like const int x, const whatever x. But there is also that whole list of pointer constants that you need to know as well. So the like the int a versus const int b. I bet that's an error actually. Yeah, because const needs to be initialized. But then there's the also int pointer c const int pointer d int const pointer e. It's gonna be mad at me because I'm not initializing it. That's fine. I'm not gonna care. Const int no int pointer const abcdf. And then finally the const int pointer const g int const pointer const abcddfgh. And then remember that these two things are the same and these two things are the same because it's before versus after the star. So I'm not going to, unless someone asks for it, I'm not going to do the whole list again because we've definitely gone over that before. But these are all the different const variables that at least I know of. Obviously, I could be wrong. If someone wants to throw out another one, but there you go. What does the second const do? What do each do? Okay, we can go over it. So for these ones, super basic. You can. I need to assign them things. So equals 0. Just equals new int 0. I'm not going to worry about their values. Okay. So then with this one, we can say A equals 1, but we can't say B equals 1. That's an error. So that's a straightforward one. But then down here, it's two things. So we can say C is new int. No, other way around. It's other way around. It's other way around. C equals 1. C equals new int 1. And then just do this whole thing. 1, 2, 3, 4, 5, 6. D, E, F. Get not G. This one's G, and then this one's H. There we go. Yep. So right here, I do usually, I was right the first time, whatever. So with this setup, C can do both of these things. D and E can't do this first one, but they can do the second one. F can do the first one, can't do the second one. And then G and H can't do either of them. So the easy one to remember are the const in both places, and then neither of them being const, but you have to remember which one of these does what here. So yeah, these two are the same, and then these two are the same. And really, like, we talked about it before, some like people think like, what was it? It was const before the star means that it's not a pointer yet, so you can't. It's const to the value, not the pointer not the pointer itself. So yeah, it's const to the value, not to the pointer itself. The pointer can change to something else. But then once const is after the star, that means it's a const pointer, and so the value of the pointer can't change. So in this case, this would be giving the pointer a new value. This one, the pointer is the same value, but the value it's pointing to is different. So something like that. However you want to memorize it, that's up to you, but you have to memorize it. Maybe I should have at one point made a mnemonic. I don't really care for mnemonics. Personal choice. Cool. So that's all the const variables. How do you pass constant parameters? It would just be the parameter looks like all these things, but without like the equals something. There has to be this like control. There we go. So passing by parameter, the parameter just looks like this without the semicolon, I guess, but the parameter would just look like this. I think we did that in project 2. We had const parameters. That's const reference, const reference. Oh, there we go. Print forward, print reverse. They had const pointers right there. Cool. But it could also be just const regular things, but const regular things regular. How to protect a class function from modifying this. That's the const after the function prototype. So at the end of the prototype, you put const. So like all the print forward, print forward, reverse, recursive, all those have const at the end because print forward should not be changing anything about a linked list. It's just getting information, printing it out. So all those are const. They protect the invoking object. They protect the this pointer. So all the different words for that makes it read only. It protects the invoking object and it protects the class from modifying the this pointer. That you could say it all the different ways. Oh, and then constant pointer down there, which I put with constant variable because I make pointers are variables in my head. Cool. Memory allocation. What does the new keyword do? So the new keyword in all situations, it allocates memory on the heap and then returns the memory address, so the information it just allocated. And so that's how pointers can point to memory on the heap. Because pointers, the value of a pointer, it's like the value that a pointer stores is on the stack. Because the size of a pointer is constant in all cases. So that can easily go on the stack, but then it points to information on the heap. What does the delete keyword do? So you delete a pointer and it goes to the memory address that the pointer is storing and deallocates that information. If you don't do that, you have memory leaks because the information won't be deallocated any other way. What is the purpose of using brackets with new and delete? So just a straightforward rule is anytime you use new with brackets, at some point there should be a delete with brackets. So that's just a straightforward one. But what they actually do, so what's the purpose, is that the new keyword with brackets allocates multiple values of memory, multiple chunks of memory, creating what you would standardly call an array. Technically, any pointer is an array if it's just a single element array or not. But yeah, any pointer in C++ is an array. But new with brackets allocates multiple elements, which is what you would standardly call, like from like Java, you would call an array. And then a delete just deallocates all that information. With the brackets, deallocates the multiple piece of information. A memory leak, I said that term a second ago, is if you don't deallocate because the deallocation won't happen by itself until your program shuts down and that memory just gets deallocated by the program. But so yeah, if you don't do that, it never gets deallocated, and that's just an issue because if you run out of memory, the memory is still reserved. It's just nothing's pointed to it, so you can't use it, and so eventually you run out of places to store information. What is a deep copy versus a shallow copy? So a shallow copy is just saying pointer A equals pointer B. And what that is saying is A now has the memory address that B had, because pointers just store memory addresses. That's all that they do. And that's a shallow copy. Sometimes you want shallow copies. However, a lot more times you want a deep copy. You want to say, make A point to the same value that B is pointing to, but at a different memory address. So changing A doesn't change B. And that's a deep copy. So that's saying that would be the difference of, I'll leave all of this. So if you did int pointer A equals new int 1, and then int to B equals new int 2, a shallow copy would just be A equals B. A deep copy would be A equals new int B. Or you could, since they're both already pointing to something, you could A dereference A equals dereference B. That would actually also be valid. That's a deep copy, because A and B are already pointing to allocated memory, so this is fine. And then you wouldn't have to delete either one of them, because if we did the other way, if we did A equals new int dereference B, to stop a memory leak, we'd have to delete A first. But the other way is fine. Okay. Cool. So that's memory allocation. Templates. What is the purpose of a template? So the purpose of a template is to make a class that can be used with multiple different data types. This is primarily for storage data types, storage classes. So if you want to make a class that's sole purpose is to store information in a specific way, you don't care what type of information is being stored, and so you can make a template so that it can be used for any type of information. So C++ uses this for like vectors, stacks, queues, whatever the hell. What is the purpose of template type name type in a class declaration? That's to say, what is the name of the data type you use in place of the any data type. So this is saying whenever I want to reference the data type that my class is storing, so it could store strings, ints, characters, but every once in a while I want to say return the string, int, character, potentially any data type. And so to do that, you make it, whatever you're returning, a type this. So a lot of times people just use T, but you can put whatever you want there. And so that's always referencing that specifically. Stack in the heap. Where does new memory get allocated? That's on the heap. So I referenced that earlier. So yeah, memory in a program is separated into two chunks, the stack and heap. The stack is a lot more efficient, a lot more organized, but because everything is right next to each other. Things get allocated on the stack at the top. So like you made a stack data structure at one point with the push and pop. Well, the stack works like a stack data structure. Everything gets pushed to the top, and it only goes right on the top. And so that means everything needs to be a known size, because once something is pushed onto a stack, you can't just change the size of it in the middle of the function, like after something's already been pushed past it. Excuse me. The heap, however, is less efficient memory but you can just like store it. It just fits memory wherever it fits best on the heap. So it can be stored in random places. Things can be deallocated. And so now there's just space there that something else could go into. So it's a lot more random variable sizes, a lot going on. So that's all just about efficiency and memory storage. Where does new memory get allocated? So when you use the new keyword, it allocates memory on the heap, but then returns an address. And that address could be allocated on the stack or the heap. That's unknown because that's just how you set up your program. But it allocates memory on the heap. Where do variables created in functions get allocated? On the stack. So all variables that you write out explicitly. So like if you like int A, int B, int C, D, E, F, all of those, even the pointers, are allocated on the stack. Because again, a pointer, the memory address that the pointer stores, that value gets saved on the stack. When you're using a pointer, you go to that memory address, and that memory address could be on the stack or the heap, but it's stored on the stack. What is a stack overflow error? How can that happen? A stack overflow error occurs when you start allocating too many things on the stack. That would be like with like a recursive function without an end condition. So it just keeps recursively calling functions. That keeps adding values to the stack because it keeps pushing stuff onto the stack and never popping it off when it's done because it's never finished and nothing ever goes out of scope. And so that's where a stack overflow error occurs. So the big three. What is the rule of big three? The rule of the big three is anytime you write one of the functions, you should probably write the other two. It's not a requirement. Nothing's ever required. But anytime you need one, you almost definitely need the other, unless you specifically know you're never using it in your code, but you would have to now avoid doing certain things. So yeah. What are the big three? It's the copy constructor, the copy assignment operator, and the destructor. What is the purpose of the copy constructor? It's when you construct an object by copying it from another. So that would be like, I don't know, do we have vectors? Oh no, we can just do it with ints. Yeah, everything can be represented with ints. So if we had int A equals 2, and then int B equals A, this line right here calls a copy constructor. Because it's constructing B as a copy to A. What is the purpose of an assignment operator? That would be like if we did int C equals 3, and then A equals C. So this one right here, nothing is being copied. Nothing's being initial, well, something's being copied. Nothing's being constructed. That's what I meant, sorry. Nothing's being constructed, but this thing right here is the assignment operator in this context. This is all construction. This is an assignment operator. So they are different. So assignment operator overloading, the copy assignment operator dictates what happens when this occurs. Now, most of the time, what you're saying here is replace the value of A with the value of C, but you can define that for yourself for your own classes. What is the purpose of a destructor? The destructor gets called whenever an object goes out of scope. So in this context, ignoring everything up there, in this context, when we get to the end of here, when we hit the return, all of these objects go out of scope and their destructors would be called. There is a default constructor. It doesn't do anything. But if you have a class that stores pointers, you want them to be deallocated. That's what it'd probably be used for. So yeah, the big three really come up when you start working with pointers because when you're using pointers, most of the time when you're doing the copy constructor or assignment operator, you want a deep copy, But most of the time, with the default copy constructor, the default assignment operator, you get a shallow copy, and then the destructor wouldn't deallocate the memory that it's storing with the pointers, and so that'd be an issue as well. Okay, I'm gonna take like 5 minutes to refresh my lungs because they're feeling a little scratchy. That's just a personal thing. So we're gonna take like a 5-minute break. Take the time to just relax, decompress what we talked about or something. I don't know, but I need to rest my lungs for a hot second. Today's just gonna be a lot of talking. Yeah. Okay. Back up. Okay. Back to the grind. Did it get closed? Oh, that's so sad. There we go. Ugh. Oh, that's not what I wanted. Fine. This is gonna open up the yeah, we were just going over the study guide. I don't care about anything else. Just the study guide is all I need. Too far. I can read. There we go. Okay, so we just did the big three, right? Yeah, debugging methods. Awesome. Okay. So my failure to open up shit hopefully was long enough for you to get back. Make sure no one's like, yeah, okay, cool. So continuing. Debugging methods. What is print debugging? So print debugging is placing cout statements into your code to print out. It could be relevant information. It could be random shit just to find where something's like, just to find what's running. But it's debugging by putting cout statements into your code. It could be used for various reasons. What is a breakpoint? It's a point in your code that when you run in debug mode, it stops. So the code just stops, and then it doesn't stop like it stops running, and then when you continue it, like you can continue it again. It stops, but you can keep it going by saying like continue or next line or something. But it stops so you can see what the code's doing at that point in time. What does it mean to step into or step out of a function? So stepping into means if you call a function, go into the function and go line by line from that function. Instead of stepping into, you could have instead step over. And so that's saying if I call the function, don't actually go line by line through the function, just go to the next line of where I currently am. So that'd be in the current stack frame. Stepping out of is kind of the opposite. So if you're inside a function going line by line and you're like, hey, I'm done with this function. I don't need to be here anymore. Let's go back to where my code was before this function was called. That's step out of. So step into and step out of are super important there. What is the call stack? So the call stack is that keeps track of the function that was used to call the last function that was used to call the current function you're in. So once you get to the end of the current function you're in, it checks the call stack to see where it needs to go back to. That's a super important concept in code because code goes line by line. And if there wasn't a call stack, it wouldn't know what line it needs to go back to. It does legitimately just keep track of a line number. When it gets into like writing code in hardware specifically, so like in comp.org, you'll get into it. The code you write, each line of code is represented at a memory address. So it actually, the call stack in that context would be what is the last memory address you need to go back to start running lines of code from there. But in higher level languages, it's literally just like what line do you go back to. So if we could actually see it by putting a breakpoint there. And so when it hit that, the call stack. So right here, the call stack, the last thing we were on is line 25. There's nothing, oh, I guess I could have made a function. There we go, call stack. So we're saying we're on line 9. Once we get to the end of the current function we're in, it says to go to line 22. So that's to say, what's the next line we go to after we're done with what we're doing? Okay. File IO. What are the 3 file IO classes we use? That is IF stream, OF stream, and F stream. What processes can we use to read/write data from a file? That's using cin. No, not cin. Sorry, but the caret operator is what I meant by that. So shrink this. So we can do get line, Lego line. We can do Lego line. Is there any others I can think of off the top of my head? Oh, read. But we haven't really gone into read much yet, so I don't know if that's gonna be an issue. We need a character pointer for this line.cstring. Does it not need? Oh, it's a const character pointer. Oh. Well, let's just make it to. We're just cheating. You see nothing. Okay. And then like 5, sure. But we haven't really gone over that, so I don't think he's gonna put that on there. But technically it is. And all this is saying, and it'd be better if I did int x. So what this is saying is from the Lego file, read 4 bytes of information and write it to the address represented by this. And so this is an integer, the address of this integer, casting it to a character pointer. So there's 4 bytes in an integer. And so this is saying it needs to be a character pointer as a single byte. And so this is writing 4 bytes from Lego and to overwrite the bytes of this integer. That's what this is doing. But these are the 3 ways that I know to get information. If there's more, I'm sorry. He probably talked about them in like his file or something. And then writing each of these has a count. Does the get line have a counterpart? Write line. There's get line. Is like a write line, string do get line. Yeah, okay. There's no get line counterpart to the way you would do the way you would do like the opposite of get line is what it just said there. It would be Lego their line. So this is the opposite of that middle one. We also do Lego line and why is this meant? Oh, this is an IF stream. Whoops daisy. Oh, stream. It's like if Lego was an let's make an F stream so we can do both. There we go. So this is like the opposite of that, and then there's write Lego dot write. We'll be going more into this thing that I'm saying that we haven't really gone over in this week, lab 4, lab 5, binary file IO. Like you're gonna see this come up, just it's not a thing yet. But I'll tell you just in case it is a thing later or something. Cool. Okay. Here we go. There we go. What do we use to separate values in a file? That's a delimiter. We've gone over that, definitely. So in a CSV file, commas are delimiters and new lines at the end of every line of data. So, but delimiter, that's the answer for that. Pointers, how do we assign a pointer to a variable? So pointers store memory addresses, so the memory addresses, so the variables they can be assigned to need to be memory addresses. We've gone over a bunch of different ways to do that with like new, obviously, because new returns a memory address, but you can also do like int pointer var equals address of another integer. So stuff like that. Anything that gets a memory address is how you can assign it. It's just the equal operator. How do you dereference a pointer? That's with the star. That's with the star right here. So this is dereference h equals 1. How do you dereference pointers to class objects? Same thing. Is it talking about the member accessor operator? Because if we had a class, let's make a string pointer or something. String pointer var2 and then var2. This is not legal. This might not be legal. Not entirely yelling at me. I don't know if legal or not. Hello. There we go. I don't know what the issue is. Okay. So then var2 length, sure. So I think it's talking about that. That's the dereference a class member object, sure. How do you get the address of variable? That's with the ampersand. Remember, outside of initialization, because in initialization, it creates a reference. So like if we said int reference b equals a, that's not memory address, but we just did it a second ago with the int pointer z equals address of a. So this is getting the address of a variable. I did that really quickly. But yeah, address of a variable right there. How do we pass pointers to a function? Just in the function parameter, just do like int pointer var. Why is this mad? There you go, it's fine. So passing a pointer to a function, just like that. What's a null pointer? So null pointer is something you can assign a pointer to be, which is the equivalent of this is no longer pointing to any at all valid memory. It's completely, the pointer is explicitly pointing to nothing. So you do that in order to be explicit about pointers, because sometimes if you don't, some pointers can have unexpected behaviors where they're still technically like you could still use them. With a null pointer, if you try to use it, it explicitly tells you with an error that that's a null pointer, don't do that. So that errors are useful, and that's a context where they are. Dangling pointer is when pointer isn't pointing to valid memory, but it's not pointing to null pointer, so it has unexpected behavior. That would be like if you deleted a point. So a pointer, if we do like, let's get rid of some of this stuff. If we did int pointer a equals new int 1, that's a valid pointer. Delete a. So if we do so at this cout statement, a is a valid pointer. Here, a is a dangling pointer. And then here, a is no longer dangling, and it's pointing to null pointer. I'm also going to get rid of all. that just so you can see it. It's like right there. Valid memory address, not 0, but not an invalid memory address, so it's dangling, and then explicitly null pointer. Okay, what is a dangling pointer? Yeah. So that's all pointers. Reference. How do you declare a reference? So that's with int a equals 1, int reference b equals a. And so now b and a are the same thing. They have the same memory address. They have the same value. If you change anything to a, you change b. Oh, close. How do you access the data a reference is referring to? Just by using it like any other variable. So cout b. That's the benefit of references, is that they just now can be used like any other variable and they work. Nothing to do with pointers. You don't have to dereference it or anything. What are the advantages of using references? Their speed, so they're just as fast as using pointers because it's not copying any memory. This can be an advantage or a disadvantage, but if you change it in one place, it changes it in another. And really, it's all about being able to use pointers without having to use any of the pointer syntax. The disadvantages of references is that you can't have an uninitialized reference. And so that means you can't have an array of references. You can't ever reassign references to some other value. As soon as they get assigned to a variable, they're stuck with that variable. They can't be assigned to another variable. That's references. Building in C++, what is a preprocessor directive? That's anything with a hashtag, like hashtag include, hashtag pragma once, hashtag define, hashtag ifndef. So all those things are preprocessor directives, and when the preprocessor runs, it reads all of those and replaces them with something else. So it reads through all of your files and either it gets rid of them and then does whatever it needs to do. So like for hashtag it define, it replaces anything you define with what you defined it as. Include, it copies over the contents of files, so on and so forth. The 3 stages of building a C++ executable, that's the preprocessor, the compiler, and the linker. Preprocessor goes through all the preprocessor directives. Compiler creates the object files out of your code, and then the linker combines all those object files into an executable. The purpose and format of a function prototype. So the function prototype is all of the stuff that's up here of a function. So we in lab 1, in project 1, gave you all the function prototypes that you're going to need. So these are all function prototypes. And then their purpose is C++ reads top to bottom, and you can have separate files. So one, it helps you break up files by having the prototypes in one place and the actual definitions in another. But then if you need to read top to bottom, if you want to write code below other code, but still have access to it in the code above, you write a prototype first, and then your code that uses the function, and then you actually define the function. And that way, as the compiler is reading your code, reading top to bottom, it understands that that function will exist with certain parameters and return types, and so it's a legal call of that function as it's making the object files. So that's what that's for. How to break up code across multiple files, that's with the C and H files. So the H files are for like class definitions, saying what's going to be there. The CPP files are where you actually, H files are for the class definition. Yes, the class definition's there, and any sort of declarations that go along with that. And then the CPP files are for their implementation. So all the prototypes that go in the H file, their implementation in the CPP file, and that's really useful for compilation time. So anytime you change a file, it has to be recompiled, and you include the H file. So as long as you don't change the H file, even if you change the CPP file, anything that includes that H file doesn't change. Then it's also just good for visuals, organizational purposes, that kind of thing. The purpose and use of the scope resolution operator. So in C++, there's a bunch of different scopes, and to move around scopes and access things in certain scopes, or say you're defining something in certain scopes, use the scope resolution operator. And that is the double colons. So let's say we did class foo public void f like that. Why are we mad? There we go. Cool. So now here we can do foo scope resolution operator f and define it. And I did this wrong because I didn't put the return type. There we go. So here we're saying we're defining this f function specifically for foo. If we didn't put it there, this would still be legal. It's just now no longer this specific function. So now there's an f function in the foo class and just this random f function that we made. That's like, so these are now in different scopes, and so you can use them differently, and you use the scope resolution operator to just be distinct between the two. So yeah, that's that. Data structures, what is a stack and how does it work? So a stack is the whole, like you put something down, then you can put something on top of it, keep putting stuff on top, but then now you can't access the bottom until you get rid of the stuff on top. So the bottom is like a separate little area. So put stuff in the stack, and then you can only access it top down. And so stacks have a first in, last out functionality. So the first thing into the stack was the last thing to come out. That could be seen as FILO. I think, yeah, first in, last out, FLIO. What is a queue and how does it work? It's the opposite, but not the opposite of first in, last out. You might think is first out, last in, but that's still a stack. First, like stack. I don't know what I said anymore, but still, a queue is that's what the English people call lines. A queue, waiting in queue, and so if people join up like this, well, this was here first, so they get seen first in the queue, and it goes like that. And so that's first in, first out functionality. FIFO. And then for a stack, the terminology is push and pop. For a queue, the terminology is NQ, DQ. And then they both have peak to see what the value is. You do need to know that. We assume for the exam that you've done all the labs and all the projects. So if we say, according to your lab's functionality, what would this do? You need to know. Okay, what is a linked list? How does it work? We just did that, so that's the whole. And we would assume doubly linked lists because that's what we made in this class. It's got a head, it's got a tail. And so you have to go through each element to access middle. Oh, that's a horrible color. You have to go through each element to access other ones. So we just did a whole project on that. What is the difference between an array and a dynamic array? So an array is any memory that's allocated information right next to each other. So we talked about that already. A dynamic array is an array that's specifically designed so it can change size. So like here it is, we could add more if we needed to, or we could remove elements if we needed to. And so that's just basically a dynamic array has to be allocated on the heap. Technically, a non-dynamic array doesn't. If you don't use a new keyword, it doesn't need to be allocated on the heap. But since we allocated on a dynamic array allocated on the heap, you can deallocate and reallocate it to make it bigger. Okay. Command line compiling. What is CLI? That stands for command line interface. That would be, you typed command in here. Did we go over that? Oh yeah, we did. Yeah, we did. So the two, I remember that. It was like from way earlier in the beginning. And I also was caught off guard by it. What is CLI, command line interface? What are two basic commands everyone should know in order to navigate directories in a command line interface? I don't remember what it is for Windows because I don't use Windows, but I think it's like dir. Yeah, okay, dir for Windows and it's ls for Linux. And then what's is it cd still? Is it cd, what do I want to go to, desktop? Yeah, so it's for Windows, it's dir and cd. Dir lists all the directories where you currently are, and cd stands for change directory, so you can change to a new one. In Linux and anything else, it's ls and cd. Ls is the same thing as dir, and cd does the same thing as cd. Gabby says, do we need to know what malloc means? Do I know what malloc means? Isn't that bad allocation? Oh, I do. I don't see it on here. Did he? If he talked about it in lecture, then yes. Yeah, if he talked about it in lecture, then definitely yes. But I don't see it on here, so I don't really know what to talk about it specifically. I'm not prepared for that. Sorry. Did he talk about it in lecture, Gabby? I don't know either. Do you remember what lecture? We can go look at it. I think that'd be dynamic memory, maybe. Oh, I don't want this. It might be in pointers. Yeah, sorry, Gabby. I got no clue. Yeah, normal. That's not. Yeah, sorry. Doesn't Fox have lecture before the exam? I think usually he does like just an ask question things. That'd be a good question for him. Yeah, I got no clue. Where the hell was I? Oh god. But I mean, it looks like, what's going on here? Let me just read this real quick. So I guess it stands for memory allocation. So it looks like a way to allocate memory without being explicitly any sort of data type. Because here it's assigning it to an int pointer, but it could be, it's just saying size of int. And so it looks like as long as it's legally the right size for an int pointer, it's fine. But it's just like it's allocating memory without a specific data type to allocate. Okay. Linked list, stack right, every vector. Yep. Face to basic. So it's dir and ls, dir and ls, and then cd. So what is a makefile and why would we ever use them? So a makefile is a way for code to be compiled outside of an IDE. So that's what a makefile is, and that's why I would use them. I guess what it is, I can like show you one, I think. Do I have one? We haven't really done a makefile yet. CMake has them. Oh. So here's a makefile. And so it's just these lines, they get run. And so this one is running these commands. So it's this rule is the first one. So if they just did make all, it would run all of these commands on each of these. It has a what compiler you're using. So I have the G++ compiler installed. What version of C++? So I'm saying the C++ 11 version. -O stands for -output file name. So I'm specifying the name of the output file that I want it to be in. So I'm saying call it PAD for pad. And then this is saying where to find the CPP files. So normally you would list all the CPP files, but I'm saying just compile all CPP files with any name. So any name for CPP files in exercise 2 folder. So that's what that stands for and all that there. But we haven't really gone over those details, so I'd be shocked if he like went into that much detail about it. But he might. And then what is a make command? So if you're in a folder and you just type make, if there's a make file in that folder, it'll run the first rule of that make file. So in this case, this is the first rule, so it's going to run all these other rules. Technically, you could write make space pad or make space unpad, so it would run that specific rule, but it runs the first rule. That's what make does, if there's a make file in there. So that's what just make by itself does. So yeah, that is the midterm study guide. It is actually 10:15. When is my next lab? I think I might just hard end it here because it takes me a hot second to get to my next lab. Yeah, it's at 10:40. Yeah, I'm gonna just do a hard end here. I usually leave here early at like 10:10 because that gives me enough time to get there. If you have any questions, since I'm ending it early, feel free to ask me on the Slack. Like DM me on Slack. I'll respond more quickly to you guys just because I normally we naturally end early, so this is fine, but I am explicitly ending it early. So yeah, let me just stop the recording now.